Hi everyone. So today we're going to look at 5 worded questions involving fractions. Now, what you're going to realize as we go through these questions is that there are actually many rules that we use when doing whole number worded questions, which apply in a similar way when we're working with fractions. There are a few differences like finding the whole, and you will see more of those examples as we run through these questions. So let's go ahead and take a look at the first question. Okay, so question 1 says, Sachin has some keychains, so some number of keychains. He gave 1/3 to his sister and 1/6 to his brother. Part A asks, what fraction did Sachin give away altogether? And part B asks, what fraction does he have remaining? Right, so just like with a whole number worded question, if I said Sachin gave away 3 to his sister and 6 to his brother, and the question asks what number did he give away altogether, what we would do is actually add 3 and 6. So the same applies with fractions, except instead of adding these whole numbers, we're going to add the fractions. So we would need to add, for part A, the fraction given away. So fraction given away would be equal to 1/3 plus 1/6, right? And what we need to do here is find a common denominator, which we would use our LCM for that. The LCM of 3 and 6 is 6. So now to make some equivalent fractions, 3 into 6 is 2, and 2 times 1 is 2, right? And 6 into 6 is 1, 1 times 1 is 1. Now we add the numerators, 2 plus 1, and we get 3 over 6, which is equal to 1/2 when we reduce it. So that is the fraction that is given away. He gave away 1/2 of all of his keychains. For B, what fraction does he have remaining? So again, when we would ask what number he has remaining, what we would do is subtract what he gave away from the total. In this case, we don't have a numerical total, but when dealing with fractions, the total or the whole is always taken to be 1. So to find the fraction remaining, what we will do is subtract the fraction that he gave away, which is 1/2, from a whole, which is 1. Right, now 1 can be expressed as any number over itself, and to make things simple, we will choose a number to be the denominator of whatever fraction we're taking away. So we'll have 2 over 2 minus 1 over 2, and we can just subtract the numerators as we have the same denominator. So 2 minus 1 is 1 over 2. So if he gives away 1/2 of his keychains, he would remain with 1/2 of his keychains, and that is a fraction that he remains with. So that's the answer for question 1. Let's move on to question 2. Okay, so question 2 reads, Kelly has 4/5 meters of cloth. She used 1/3 meters to make a sash. How much material does she have left? Now, as I said before, if we were working with whole numbers, and let's say Kelly had 4 meters of cloth and she used 1 meter to make a sash, how much material would she have left? Well, we would just take away 1 from 4, right? The same principle now applies with the fractions. This is a measurement, 4/5 of a meter, which is 80 centimeters, but we're going to use fractions, and 1/3 of a meter used. So what we're going to do is the material left, or her remaining material, is going to be 4/5 minus 1/3. And again, we have different denominators, so we are going to have to bring it to a common denominator. We'll use the LCM of our denominators here, and the LCM of 5 and 3 is 15, right? So to convert to equivalent fractions, what we do is we can say 5 into 15 is 3, and 3 times 4 is 12, right? Likewise, for 3, 3 into 15 is 5, and 5 times 1 is 5. Now we have the same denominator, we can just subtract the numerators, and we have 12 minus 5, which is 7/15. So Kelly will have 7/15 meters of cloth left after she makes her sash. And that is the answer for question 2. Let's go into question 3 now. Okay, so question 3 reads, Michael has 30 toy cars. 2/5 of them are red and the rest are blue. How many of Michael's cars are A, red, and B, blue? So what this question is telling us is that 2/5 of Michael's 30 cars are going to be red, and they ask for the number of red cars. So not the fraction of red cars, but now the number, the actual numerical value of red cars that Michael owns. So that of in the question, the 2/5 of, is telling us that we need to multiply, right? That word of in terms of fractions and worded questions, it really tells us that we need to multiply. So the red cars that Michael owns, the number of red cars, would be 2/5 of 30, and of would be multiplied, so 2/5 multiplied by 30. Right, now we can go ahead and multiply this fraction by this whole number. We can cancel the denominator 5, 5 into 5, 1, and the numerator 30. 5 into 30 is 6. Now there is nothing left to cancel. We cannot cancel a numerator with a numerator, so we can't cancel that 2 and 6. So what we're going to have to do now is just multiply the numerators. So 2 multiplied by 6 is 12, and 1 multiplied by 1 is 1 in the denominator. 12 over 1 is really just 12. So that means that Michael has 12 red cars, right? So let's just say 12 cars here. And that's your answer for part A. Now moving into part B, we are asked how many of Michael's cars are blue, right? Now there are 2 ways to do this. Because Michael only has red cars and the rest are blue, so red and blue cars alone, what we can do is we can say that the number of blue cars is simply 30, which is his total number of cars, minus 12, which is his red cars. 30 minus 12 is 18 cars, right? Or, so this is another way, we can actually use fractions again. Or, let's find the fraction of his cars that are blue. So the fraction of blue cars is going to be, now the whole in terms of fractions, his 30 cars is represented by the number 1 minus 2/5, which is his red cars, the fraction of his cars that are red. That's going to be 5/5 minus 2/5, because 1 is any number over itself. So the fraction of his cars that are blue is 3/5, right? 5 minus 2 is 3. So the fraction of cars that he has that are blue is 3/5. And we can go ahead and find the number. So I ran out of space here. I'm just going to put it up here. The number of blue cars. If the fraction of blue cars is 3/5, it means 3/5 of his cars are blue. So we can say 3/5 of his 30 cars are blue. And again, we can cancel denominator. 5 into 5 is 1, and the numerator 5 into 30 is 6. Then multiply our numerators. So 3 times 6 is 18, and over 1 times 1, which is 1, 18 over 1, which tells us 18 of his cars are blue, right? So we get the same answer and 2 different ways to work it out. So this is your answer for question 3. Let's move on to question 4. Okay, so question 4 says 3/8 of Jeremy's books is equal to 30. A, how many books does Jeremy have in total? And B, 1/4 of Jeremy's books have red covers. So how many books have red covers? So for part A, this is where we deviate a little bit from the whole number worded questions. What they told us, the information that they gave us, is that 3/8 of Jeremy's books is equal to 30. So I'm going to put that down. 3/8 is equal to 30. Now they ask, how many books does Jeremy have in total? Right? So they're asking for the number that represents the whole. And they gave us a fraction, 3/8, that is represented by this quantity, 30. So how do we go about finding the whole? Well, the whole is 30, the quantity, multiplied by the reciprocal of 3/8. Now, what is the reciprocal? Pretty simple. All you need to do is switch the numerator and denominator. So instead of multiplying by 3/8, you multiply by 8/3. Now, this is important. You can only do this if you have a quantity, that's 30 in this case, that is equal to the fraction 3/8. Okay? So the quantity must be equal to the fraction in order for you to be able to go ahead and multiply the quantity by the reciprocal of the fraction to find the whole. If the quantity is not equal to the fraction, then your answer for the whole is not going to be correct. So you have to make sure that your quantity is equal to your fraction before you go ahead and flip the fraction and multiply by the quantity. We know that 3/8 is equal to 30 because the question told us that. Now we can go ahead and find our whole. Now you can think of 30 as 30/1. And let's go ahead and cancel. We can cancel 3 into 3 is 1 and 3 into 30 is 10. Nothing left to cancel. So 10 times 8 would be 80 over 1 times 1, which is 1. 80/1 is 80. So Jeremy has 80 books in total. Now for part B, very similar to question 3 that we just did, 1/4 of Jeremy's books have red covers, and they ask how many books have red covers. So they gave us a fraction with red covers, and they ask us for the number with red covers. So the number of books with red covers, so red covers would be equal to 1/4 of Jeremy's total number of books. So 1/4 of 80, and of, as we had mentioned before, means to multiply. So 1/4 of 80, right? We can cancel. 4 into 4 is 1. 4 into 80 is 20, right? 1 times 20 is 20 over 1 times 1, which is 1. So 20/1 is, of course, 20 books. So that means that 20 of Jeremy's books have red covers. And that's your answer for question 4. Let's move on to question 5. Okay, so question 5 says, Francie has some marbles. 1/5 of them are red, 2/3 are blue, and the remaining 30 are yellow. A, what fraction of the marbles are yellow? B, how many marbles does Francie have in total? And C, what is the difference between the number of blue and red marbles? So let's go ahead and take a look at part A. What fraction of the marbles are yellow? Now the question doesn't give us a fraction that are yellow, it gives us a number that are yellow. So we're going to have to work with the fraction that they gave us for red and blue to find out the fraction that are yellow. So the first thing I'm going to do, the first step I'm going to take is I am going to add the fraction of red marbles to the fraction of blue marbles. Now they told us 1/5 of the marbles were red and 2/3 of the marbles were blue. So for 1/5 plus 2/3, of course, the denominators are not equal, so we need to find a common denominator. We'll use the LCM of the denominators, and the LCM of 5 and 3 is 15. Right, so now we can say 5 into 15 is 3. 3 times 1 is 3. And we can say 3 into 15 is 5. 5 times 2 is 10. Now we have equivalent fractions. We can add the numerators. 3 plus 10 is 13 over 15. So 13 over 15 represents the fraction of red marbles plus the fraction of blue marbles. Now, to find the fraction of yellow marbles, we know that Francie only has red, blue, and yellow. So what we can do to find the fraction of yellow, so yellow as a fraction, we can now take away the fraction of red plus blue from the whole. Right now, the whole in terms of fractions, as previously discussed, is 1. So we'll take away 13 over 15 from 1 whole. And 1 whole can be represented as any number over itself. So we have 15 over 15 minus 13 over 15, which is 2 over 15. So 2/15 is the fraction of Francie's marbles that are yellow. And that's your answer for part A. So next, what I'm going to do is part B, and part B asks, how many marbles does Francie have in total? So they're asking for the whole. Now we know from the previous question that to find the whole, what we need is a quantity and a fraction that represents that quantity. So, do we have that in this question? Yes, we do. We actually just figured out the fraction for yellow marbles, and that is 2/15, right? So that's what question 1 asks. What fraction of the marbles are yellow? And that's 2/15. And the question actually gave us the number, right? 30 are yellow, right? So that's the numerical value of the yellow marbles. And the fraction, which we just found, is 2/15. So I'm going to do part B over here. That must mean that 2/15 is equal to 30. So our whole, we're just going to take the quantity 30 over 1 and multiply by the reciprocal of 2/15, which is 15 over 2. Now what we do is we can cancel. 2 into 2 is 1, 2 into 30 is 15, and from our squared numbers times tables, we have 15 times 15, which is 225. So Francie has 225 marbles altogether. That's her whole number of marbles. That's your answer for part B. Now let's move on to part C. Part C asks, what is the difference between the number of blue and red marbles? Now, there are two ways to go about doing this question. The first way is we can find the number of blue marbles and then the number of red marbles, and then we can subtract the two. That's probably the most straightforward way to do that. So let's look at that method before we move on to the other. So we know that from the question, the number of blue marbles, so I'll find the number, this should be C, not B. The number of blue marbles is 2/3, and that's going to be 2/3 of the whole number. So that's 2/3 of 225. So we'll take 2/3 multiplied by 225. Let's cancel and see what we get. So 3 into 3 is 1. 3 into 225, well, 3 into 2 cannot. 3 into 22 now is 7. Remainder 1. And 3 into 15 is 5. Now we have 2 times 75 is 150. And over 1 times 1, which is 1. So 1 over 150 over 1 is 150. So Francie has 150 blue marbles. And the number of red marbles is going to be 1/5 of 225, because the question says 1/5 of her marbles are blue. We can cancel again. 5 into 5 is 1. 5 into 225 now. 5 into 2 cannot again. 5 into 22 is 4. Remainder 2. And 5 into 25 is 5. So 5 into 225 is 45. Now we multiply 1 times 45 is 45 over 1 times 1, which is 1. So Francie has 45 red marbles, right? And we want to find the difference between these numbers. So the difference would be 150 minus 45, which is 105 marbles. And that's your answer for part C. This is a perfectly good method to use, but there is another method that I want to discuss, and that is using the fractions to find it. So I'm going to draw a line here, and let's look at part C again. So we know that 2/3 of the marbles are blue, 1/5 of the marbles are red. So let's find the difference in red and blue, but as a fraction this time. So that means I'm going to take the fraction of red marbles and I'm going to take that away from the fraction of blue marbles. So that is now 2/3, which is the fraction of blue marbles, minus 1/5, which is the fraction of red marbles. Now 2/3 minus 1/5, we need to find common denominator again. Use the wrong pen for that. We'll find the common denominator again, which is 15. Now from part A, we actually know that 2/3 is 10 over 15 and 1/5 is 3 over 15. So we'll have 10 minus 3, which is 7 over 15. Now this 7 over 15 actually represents the fraction of blue marbles minus a fraction of red marbles. So blue minus red, but as a fraction instead of a number. Now, in order to go ahead and find out that number, what we can do, so just the difference now, what we can do is actually multiply 7/15 by 225. And we should get the 105 that we got in the first method, right? It's the same answer that we should get, just a different method that we're using. So let's try and do that. 7/15 by our whole, which is 225. And we can cancel. 15 into 15 is 1. 15 into 225 is 15. And 7 times 15 is 105. Right now, if you need to do that separately, by all means, go ahead. If you need to work it out vertically, that's fine. But 7 times 15 is 105. So that means that the difference between the red and blue marbles is 105. Right? So that is your answer for part C and your answers overall for parts A, B, and C. As you can see, for part C, we used 2 different methods, but we got the same answer. Right? So that brings us to the end of the video. I hope working with fractions seems a bit easier to you now. Remember, if there was something you did not understand on the first viewing of this video, you can always replay that part to get a better understanding. Thank you so much for watching, and I will talk to you in the next one.